Some of my other recordings have shown you the hardware and how I connected it up. The purpose of this video is to show you how to install and use the tools that are needed to get the NodeMCU modules working for HiveLive. So first thing you're going to need is the firmware flashing software, and if you do a search for ESP8266 flasher, you will be able to go straight to the GitHub for this, and you can download it. It's a simple install. To save time, I've already got it on my computer, but to actually make sure we get to the right serial port, it's best if we plug in the NodeMCU first. So we'll connect this. You heard the Windows sound there saying we've connected. So now here is where I installed a shortcut to the flasher, and I fire it up. Now it's already detected that the module is on COM port 3. So we know that's good because COM port 2 is the built-in port for this virtual machine. Just a note about that. I'm doing everything with Windows here because I think most people would be wanting it, and also I'm a fairly new Mac user and some of these tools I haven't mastered on the Mac yet, to be honest. So the first thing we need to do is select our firmware, which has been loaded to the Dropbox already for you. I'm going to find it down in here, Documents, Project HiveLive firmware, and the latest one I've got is January there. So I just open this and you see that's correctly in there. I now go back to Operation, and all I need to do is click Flash. And if you look down at your NodeMCU module, you will see the little blue LED flashing, and it's going to take a couple of minutes to do that, so we're just going to take a little breather while that happens. So there we can see the little tick on the screen here telling us it's completed successfully. So I'm going to close down that tool now, and the next tool we're going to need is our ESP LoRa, which is, don't be worried about this being a Russian site. I've been using this for months, and this software is, as far as I can tell, quite safe to use. It gives you an environment for developing code for these modules, but to tell the truth, I prefer to write my code externally and just use this to load the software and diagnose it when it's running. So we go and install that. It's quite simple. You require Java for this, I think. So once it's installed, you will have something like this running. And there we go. Now once again, it's detected COM3 is available on this computer, so it's going to use that. If I try and open it, we'll probably see not much happening at the moment, so I'm going to press the reset on the module, and we can now see it's because it's seen it as a reboot from the first firmware build, it's going to format the file system. So that will take a couple of seconds, and then we'll have a board that's ready to be programmed with our scripts to run things. The way that these things work, they always look for a file called init.lua. Now there it says cannot open init.lua. Now you can just build a huge program of init.lua, but it makes it very hard to troubleshoot because these things cycle through their boots very quick, and if you make a mistake on your programming, you can get it into a hung state where the only answer is to reflash the image onto it, because you just can't recover from that. What we will look at here is you can see the modules I've installed in the firmware already. So we have the BME for the pressure sensor, DHT for temperature, file is fairly obvious, GPIO allows me access to the pin outs to actually connect things, HX711 is the A to D converter for the scales, MQTT is for the protocol for transmitting our information, and the other one's obviously that Wi-Fi, fairly important to us. So now what I've done is I've built this in such a way that our files are modular, and so we have you can easily change the init file to reflect just the bits of code you want to run, or you can put dummy secondary ones there. So we're looking for Lua scripts here, so I should be looking under production. So these files should be live now. Because I'm running a virtual machine, I have problems with some of the key combinations, so I need to upload these individually. That was collector, config, init, setup, which is the one for the Wi-Fi code. You may have seen all these already on the Dropbox and had a good look through to see what they do. Wait is in this case a dummy file which we need to have just for completeness of the code. So now I've got all my modules installed on there and all the firmware is up to date, so it's ready to go. All I need to do is issue another reset on the box, and we'll see now it's building, it's running through, connecting to the IoT.net Wi-Fi. We can see there's some feedback information about it. So we've got an IP address. We can see we're connected to our Wi-Fi. I can see my node address, which is the unique number assigned to this module, which means then in the database I can name that to whatever Hive I want and keep that information. So this module is as dumb as it can be. It only sends its serial number, it doesn't need any other programming. Obviously you'll notice that I've got error temperature humidity sensor because basically I've just got the bare board, I've not connected any hardware to it, so it's just gone to sleep as having sent an error. So the next thing we need to do is understand where that message has gone. So we'll move on to the next set of this, which is going to be looking at our internal server software. The next thing we're going to need to look at, just to diagnose this at the moment, is a program called MQTT Spy. Now this is great, it allows you to actually monitor the traffic on MQTT. I'm not going to go too much into detail, but basically it's a lightweight protocol developed specifically for Internet of Things type devices, and so the message is sent from the NodeMCU module to an MQTT server running on my Raspberry, which works as the machine publishes to it, and then we can subscribe to any particular information that interests us on that server. So if you go to the GitHub and install this, you'll end up with the program I've already installed, which is here. So this one requires Java, so again it's a Windows thing. As you can see, we've got one configuration already there, but to show you how it's done, I'm going to make a new one for now. So I'll make a new connection here. We can just call it test and put test in here, and we give it our address, which is my local server. Okay, and we're going to set some security with a predefined name. Now I'm using here HiveLive because that's the original name of this project, before I realised that there was a trademark name there. So the project is now called HiveLive, but in some parts of the code it's still hard coded that I'm going to need to use this for a while, but obviously as we build more servers then it won't be necessary. Apply that and open the connection. Okay, so we can see we're opened on our broker. The first thing we need to do is subscribe to some messages. The way that this thing works is that we have a topic. That's my top level topic, and then a wildcard underneath, because basically you want the top level topic to describe your unique Hive name or your unique program name. Maybe you're on a public broker, so you need to do that, and then underneath you'll see we have various other subtopics, but by subscribing with the wildcard I will get everything that's coming in. So I've done this now. You can see I'm on this Hive data tab, there's nothing here. If I press the button on my controller again, what should happen is it should reboot and report the error message in. So there you see in real time that's happened. We've got this module number, it's reported an error, and there's a content message for that, which is all specified in my files. So this is the first way we're going to test our system. So once you've built one of your modules, you can test it quickly like this to prove it's working before even worrying about building the database or anything to start capturing the data. That's the way I developed it. So we'll close down there now, and later on we'll be talking about how we build the server itself.